All right, hey guys, we are going to go ahead and start looking at some of these trig functions and their graphs. We've spent the last couple days really going over how to solve for these trig expressions. And so today, like I said, we're going to look at the graph of one of our functions, specifically our sine function. All right, so for today, we're going to graph f of x equals sine of x. That's the first function we're going to look at. So I already gave you a table of values and I put in all of the x values that we're going to look at. And what we're going to start off with is solving, right? So when x equals 0, what's our f of x? So what I'm going to do is to the left of my table, I'm going to put down my terminal point. So right here, right, I'm going to say terminal point from, this is my terminal point from the unit circle, right? So at 0, we know our terminal point is 1, 0. So we can use that to help us solve. If I want to solve for the sine of 0, we know sine is my y value, and my y value at 0 is going to just be 0. So I'm going to put that into my table. All right, at pi over 6, we got to think back to our unit circle, and our terminal point at pi over 6, we know to be square root of 3 over 2, 1/2. And so if I want to solve for the sine of pi over 6, since sine is my y value, my sine of pi over 6 is equal to 1/2. So I'm going to go ahead and put that in the table as well. All right, and I'm going to keep going. So pi over 4, my terminal point at pi over 4, we know to be square root of 2 over 2, square root of 2 over 2. If I want to solve for the sine of pi over 4, once again, I want my y value at pi over 4. Right, so this is just going to be square root of 2 over 2. All right, pi over 3, same thing. Terminal point at pi over 3 is 1/2 square root of 3 over 2. And the sine of pi over 3 is going to be my y value at pi over 3, which is going to give me square root of 3 over 2. All right, and when I get to pi over 2, I'm a quarter of the way around my circle. At pi over 2, we know our terminal point is 0, 1. So the sine of pi over 2 is just going to be equal to 1. All right, we're going to go ahead and fill out this whole table, right, for sine of 2 pi over 3, 3 pi over 4, and so forth. All right, so I added the terminal points next to all of our radian measures from quadrant 2, and we're going to use the same technique to find our f of x. If I want to solve for sine of 2 pi over 3, we know sine is my y value at 2 pi over 3. So I'm going to go ahead and say there's my answer. All right, the sine of 2 pi over 3 equals the square root of 3 over 2. My terminal point at 3 pi over 4 is negative square root of 2 over 2, square root of 2 over 2. And since sine is my y value, the sine of 3 pi over 4 is square root of 2 over 2. Right, sine of 5 pi over 6, I look at my y value at pi over 6, and we can see that that's going to be 1/2. And then finally, the sine of pi, I do the same thing. I look at my y value at pi, and I can see that the sine of pi is 0. Looking at all of our terminal points in quadrant 3, we're going to use the same technique, right? If I want the sine of 7 pi over 6, I want my y value at 7 pi over 6. So I'm going to go ahead and say sine of 7 pi over 6 is negative 1/2. Sine of 5 pi over 4, my y value at 5 pi over 4 is negative square root of 2 over 2. Right, and at 4 pi over 3, the sine of 4 pi over 3 is going to be a negative square root of 3 over 2. Right, and I finish off quadrant 3, I go into that 270, that negative y-axis. Right, the sine of 3 pi over 2 is just going to simply be negative 1. So remember, we use those terminal points to help us solve for sine. All right, and now we can go ahead and finish off that fourth quadrant using the same technique. The terminal point at 5 pi over 3 is 1/2 negative square root of 3 over 2. If I want the sine value, I want my y value at 5 pi over 3. So that's just going to be negative square root of 3 over 2. Right, my sine of 7 pi over 4 is going to be negative square root of 2 over 2. The sine of 11 pi over 6 is going to be my y value at 11 pi over 6. So that's simply going to be negative 1/2. And then finally, we're going to make it all the way around the circle at 2 pi. And the sine of 2 pi is going to be equal to 0. Now to make this a little bit easier for us to graph, I'm going to actually go ahead and write the decimal form of some of these values. This isn't something we normally do when we're solving, but when we're trying to figure out where to plot it, it'll make it a little bit easier. All right, 0, well, we don't really have to do anything fancy with that. That's just going to stay 0. 1/2, right, that's going to be 0.5. If we take the square root of 2 and divide it by 2, that gives us 0.707. And if we take the square root of 3 and divide it by 2, we end up with 0.866. Now that we've found the decimal form of pi over 6, pi over 4, pi over 3, we know that this decimal form is just going to repeat as we go into quadrant 2, quadrant 3, and quadrant 4. The only thing that's going to change is whether it's positive or negative. Right, so if we keep going through and write in all of these decimal forms, right, we're going to keep it at 1. Remember, square root of 3 over 2, that's that 0.866. Square root of 2 over 2 is that 0.707. 1/2, 0. Now when we get into quadrant 3, since this is sine, all of our y values are now going to be negative. So we have negative 0.5, negative 0.707, negative 0.866, negative 1. And then in quadrant 4, y is negative, so sine remains negative. Right, we have negative 0.866 again, negative 0.702, negative 0.5, and we end at 0. All right, so we find those decimal forms, like I said, so that way when we come over here and try to graph these, it just makes it a little bit easier to figure out exactly where it falls on the y-axis. Now, if you notice this graph, right, you'll notice the x-axis is broken up into a scale of pi over 6. This is to make it easier for us. When we're building our x-axis, guys, pick a scale that matches your x values, right? So I'm in radians. I'm going to go ahead and give myself a scale that matches my radian measures. Now pi over 4 is not on this scale, so I'm going to go ahead and add it in between all of my pi over 6 and pi over 3s, so that way I have a nice mark and I know when I'm graphing these points. So I went ahead and added in a little tick mark in between pi over 6 and pi over 3, in between 2 pi over 3, 5 pi over 6, okay, 7 pi over 6, 4 pi over 3, and 5 pi over 3, 11 pi over 6. I just added in that little tick mark for all of my pi over 4s. Now I'm going to go ahead and just start graphing. So the first point that I'm going to plot is going to be the point 0, 0. I'm going to go to my graph. When x equals 0, my y value is also 0. First point. Then I'm going to go ahead and plot the point pi over 6, 0.5. So when x equals pi over 6, my y value is at 0.5. So I'm going to come over here and plot that one as well. All right, we're going to keep going. Pi over 4. When x equals pi over 4, my y value is at about 0.7. So I'm going to come up here and plot my 0.7. And then at pi over 3, my y value is at about 0.866. So I'm going to go ahead and plot that one as well. Finally, at pi over 2, my y value is 1. I've made it all the way through that first quadrant. Okay, and we'll keep doing it. So let's go ahead and plot those points for the second quadrant as well. So I went ahead and plotted all of my points for quadrant 2, all right, and they repeat and they start to go back down towards 0. All right, we're going to continue on doing this for quadrant 3. So at 7 pi over 6, now I'm at negative 0.5. So I'm going to go ahead and plot that point. At 5 pi over 4, I'm at negative 7.7. So I'm going to go ahead and plot that point as well. And at 4 pi over 3, I'm at negative 0.866. Right, and that takes me to 3 pi over 2, which is at negative 1. So I just went ahead and plotted all of my values from quadrant 3. Right, all of those, all the way to 3 pi over 2. And that's all of these points right here. All right, and then you'll notice as we enter quadrant 4, right, the values do start to repeat themselves again, but this time they are now headed upwards, right, back towards 0. All right, so our first one that we're going to plot is 5 pi over 3. Okay, when x equals 5 pi over 3, our y value is negative 0.866. So I'm going to go ahead and plot that one first. Let me try that again. That wasn't a good point. There we go. All right, and then we have at 7 pi over 4, we're going to be at negative 7.02. At 11 pi over 6, we're back at negative 0.5. And finally, if we go all the way around to 2 pi, we're back at a y value of 0. All right, so we just finished plotting all of these points through quadrant 4 and finishing at 2 pi. So the reason why we plot all those points is because I want you guys to see exactly where the shape of this function comes from. So just like any other graph that we would plot, once we go ahead and plot all of our points, we're going to connect them with a smooth curve. So once you connect all of your points that you plotted, this is what you end up with. This is called one period of our sine function. We'll talk more about the characteristics of them, but for today I just wanted you to see it, see what it looks like, right? And we are going to use this same technique for you guys to solve or to graph cosine. Right, so on the back of your notes, you'll see the exact same setup. You'll see a table. All of your x values are in there. We're going to find all of our corresponding y values for all of our significant values, 0 to 2 pi. We're going to plot them, and we're going to look and see what kind of shape and what kind of graph the cosine function gives us as well.